Alright, so we have a first order reaction here. Both reactants are in first order. So when we write our rate law, it would look like this. First order means that the concentration of hydroxide is to the first power, not squared or anything fancy like that, and same for the methyl bromide. So we're given all sorts of numbers and information, but what we really want to find is the rate constant. That's K, so let's solve for K. I'm going to divide both sides by the concentrations of the reactants. How does that look? Pretty good? Alright, now let's put in our numbers. Now we have to get all that information out of the question. Now again, because these reactants are both first order, it's implied that there's a power of 1 that they're both being raised to. We just don't need to write it usually, so we don't. But when we do the math, we get 172. But the harder part here is figuring out what are the units of K. To do that, let's figure out what units were these numbers we were multiplying. Rate is always in molarity per second, or concentration per time. It doesn't have to be seconds all the time. But in this case, it is. And we divided by these numbers that are both in units of molarity. So we basically divide by molarity twice. So here's what the math on our units looks like. So we got molarity per second divided by molarity squared. We end up with canceling one molarity and end up with one molarity in the denominator. So it should look like this, which we can also write like this. So figuring out the units was part B. Part C is what would happen if we tripled the concentration of hydroxide. Well, the rate is proportional to the concentration of hydroxide. So if we multiply by 3 up here, the rate necessarily has to get tripled. It sounds pretty simple, right? That's because this is a first order reaction, or it's a first order reactant. If it was a second order reactant, that would mean that the OH concentration is squared in our rate law equation, and then we would have to square our 3 if we're tripling it, and we'd end up with 9 times the rate. But that's not what this was asking.